Hey everyone, and welcome back to the channel. Today, we're venturing out into the cosmos, not just to admire the stars, but to unlock their hidden riches. We're talking about asteroid mining, a concept that sounds like science fiction, but is rapidly becoming a very real, very profitable, and potentially trillion-dollar frontier. Get ready to have your minds blown. So, what exactly is asteroid mining? Imagine giant, cosmic treasure chests orbiting the Sun. These aren't just barren rocks, they're packed with valuable resources like rare earth metals, platinum, gold, and even water, resources that are becoming increasingly scarce and expensive here on Earth. The idea is to send robotic probes and eventually human crews to these asteroids, extract these materials, and bring them back for use on Earth or in space. You might be thinking, but we have plenty of resources on Earth, right? Well, not exactly. Our planet's finite resources are under immense pressure from a growing global population and increasing technological demands. Mining on Earth is becoming more environmentally destructive, more costly, and the easily accessible deposits are running out. Asteroid mining offers a sustainable, long-term solution to this resource crunch, promising a future where our technological advancement isn't limited by what we can dig out of our own planet. You might be thinking, but we have plenty of resources on Earth, right? Well, not exactly. Our planet's finite resources are under immense pressure from a growing global population and increasing technological demands. Mining on Earth is becoming more environmentally destructive, more costly, and the easily accessible deposits are running out. Asteroid mining offers a sustainable, long-term solution to this resource crunch, promising a future where our technological advancement isn't limited by what we can dig out of our own planet. Now, let's talk treasure. Asteroids are broadly categorized into a few types, and each holds different goodies. C-type, carbonaceous. These are like cosmic sponges, rich in water, yes, water, and organic compounds. Water is crucial for space exploration. It can be used for drinking, growing food, and perhaps most importantly, as rocket fuel by separating it into hydrogen and oxygen. S-type, stony, these are metallic rich, containing nickel, iron, and a good amount of precious metals. M-type, metallic, these are the real heavyweights, almost entirely made of metals like iron, nickel, cobalt, and incredible concentrations of platinum group metals, PGMs, like platinum, palladium, and rhodium. A single M-type asteroid could contain more PGMs than have ever been mined in Earth's history. This isn't just about cool science, it's about potentially reshaping the global economy. Imagine flooding the market with platinum, driving down prices for everything from catalytic converters to jewelry, or having an endless supply of critical materials for electronics. The economic impact could be staggering. Some estimates suggest that a single asteroid, just a few hundred meters across, could hold resources worth trillions of dollars. This isn't small change, this is a paradigm shift. It could create entirely new industries, thousands of jobs, and fundamentally change how we value and acquire resources. Of course, it's not all sunshine and space diamonds. Asteroid mining comes with immense challenges: distance and travel time. Asteroids are far away. Getting there takes time, powerful rockets, and precise navigation. Harsh environment, the vacuum of space, extreme temperature fluctuations, and radiation are unforgiving. Equipment needs to be incredibly robust. Microgravity, mining in microgravity is a whole new ballgame. How do you anchor to an asteroid? How do you collect materials without them floating away? Extraction and processing, developing efficient and automated ways to extract and process materials in space is a monumental engineering feat. Cost, the initial investment for R&D, mission planning, and hardware is astronomical. So, how do we tackle these challenges? Scientists and engineers are already developing ingenious solutions. Robotic probes, early missions will likely be fully automated, using advanced AI and robotics to scout, prospect, and even begin preliminary extraction. Asteroid redirect missions. Concepts exist for capturing small asteroids and bringing them into Earth orbit or lunar orbit, making them more accessible for mining. In situ resource utilization, ISRU, this is key. Instead of bringing everything back to Earth, we could process materials in space. Imagine 3D printing parts for spacecraft using asteroid metals, or producing rocket fuel from asteroid water right where you need it. This dramatically reduces the cost and complexity of space missions. This isn't just government agencies anymore. A new breed of private companies, backed by visionary investors, are at the forefront of this space race. While some early pioneers like planetary resources and deep space industries faced challenges, their work laid crucial groundwork. Today, giants like SpaceX and Blue Origin, with their focus on reusable rockets and reducing launch costs, are making asteroid mining a more viable prospect. Countries like Luxembourg are also positioning themselves as hubs for space mining, offering legal and financial frameworks to support this nascent industry. Now, for a fascinating and complex aspect: who owns these asteroids? The 1967 Outer Space Treaty states that no nation can claim sovereignty over celestial bodies. But it doesn't explicitly address resource ownership. This has led to debates and new legislation. The US and Luxembourg have passed laws allowing their companies to own resources they extract, not the celestial body itself. This is a rapidly evolving legal frontier, and international cooperation will be crucial to avoid a Wild West scenario in space. Beyond the immediate financial gains, asteroid mining represents a critical step towards humanity becoming a truly spacefaring civilization. Imagine permanent lunar and Martian bases, built with materials sourced from nearby asteroids. Space habitats, entire cities orbiting Earth, constructed from space-mined metals. Interstellar travel, water from asteroids fueling missions further into our solar system, and perhaps beyond. This isn't just about resource extraction, it's about enabling our expansion into the cosmos, breaking free from the constraints of a single planet. Asteroid mining is no longer the stuff of dreams. It's a bold vision backed by cutting-edge technology, significant investment, and the unwavering spirit of human ingenuity. While the challenges are immense, the potential rewards, both economic and existential, are even greater. We are on the cusp of unlocking a trillion-dollar frontier that could reshape our future, both on Earth and among the stars.